Welcome everyone. Now we are going to learn about the EU, which is execution unit. So let's proceed with the EU. So what is the EU in the first step? EU. Well, as the name suggests, this is our execution unit. Execution unit. Well, the most important thing about the EU is communicating with the BIU. It is giving the instructions to the BIU that what data needs to be fetched and all that kind of things. And here in the EU, actually everything is going to happen. Execution is going to happen. And that's what we mean with the everything. So this is the main fundamental point. So just to understand it in quite clear basis, let's write few of the things so that we can understand its use basically in the microprocessor, that what it actually performing, which kind of the artist EU is. So EU gives instructions to BIU, instructions to BIU, bus interface unit, stating from where to fetch the data and then decode, then decode and execute, obviously, and execute those instructions, let me write it clearly, those instructions. What else we can have here? Its function is just to control the operations. So on a separate note, we can say it controls the operations, all the kind of operations like addition, subtraction, or editing, or whichever kind of operations you can imagine. It is operating everything. So control of operations, actually I should write the operations, I guess. So control of operations is happening in the EU. It is having ALU, so as to direct it, it performs the operation over the data through BIU. So this is the execution. Well, how we can simply understand it? Well, it's quite a bit of thinking part that I am having a question. Well, which kind of question you are having, my dear friend? So the clarity of the concept here is that execution is actually executing the things, like there is a board, and the board you are writing 2 plus 2 and equals 2. So as to solve this, the 2 is getting stored in the memory, addition is stored in the memory, 2 is stored again in the memory, this is the second 2, this is the A, this is the B, that kind of thing, and equals to stored in the memory circuit, everything is happening. Execution unit is deciding that what it has to activate, which circuit it has to activate to solve the answer. So execution unit commands the BIU to get all these datas, and then it's going to execute and finally give us the result as 4. That's the overall idea of it. Well, to understand its whole story, we should explore its basic. Well, here as you can see, there are AX, BX, CX and DX. So let's learn this one in a separate way. We have AX, BX, CX and DX. Well, you surely have noticed that I have written A as and AL, and the same way BH, BL, CH, CL, and finally DH and DL. Well, H is simply high, L is simply low. What does it mean? Well, as we have discussed that everything happens in our subject in the digital electronics and the assembly language, we are using hexadecimal number system for our microprocessor. So what we are going to write? We are going to write it in this way, like 9AH. H is denoting that it's hexadecimal, A is on the 11th number. So we can write 11 as 2 to the power 0 to the power 1 to the power 2 and to the power 3. So 8 plus 3 is 11. So 8 plus 3 is 11. So this is our 11. And for the 9 we require just 8 and 1. So this one and this one. So this one is low, this one is high. That's it, nothing much really. So both are individually 8-bit, 8-bit AH, and similarly 8-bit, 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 individually 8 bits, and this is also 8-bit. Well, if you want to use once, if you want to use, let's say I just want to use CL, C low, so I can use it this one, or if I want to use both of these, I can do that too. I can do this too, and in that case I'm going to say it that it's DX, extension, X is extension, that kind of a thing we can use. So that will going to give us 16-bit, the full capacity of our processor, 16-bit. Okay, so I hope you have got the general idea of it. And what is my purpose of using the word general here? Because this is right here that we have seen are called as general purpose registers. These are general purpose, PURPOSE registers. So we can just call it as GPR, general purpose register. My writing is a little messed up. Okay, that's fine. Now we can proceed with this one. So what is individual meaning of these things? Well, why I'm saying individual? Let me give you a clear idea by elaborating everything so that we can have the better clarity of the concept. So individual storage is 8-bit in our general purpose register. And what 8-bit can? It can be AH, BH, CH, DH, or again AL, BL, CL, and DL. And if we choose to do it together, that will going to give us 16-bit, and we just write the X, and here we can have A, B, C, or D. Why this is called as general purpose register? Because as a programmer we also want some space. Even in the memory we want some space so as to execute the things. Till now we are just fetching the data from the memory. We want some space, obviously. So what we wish to do, we have solved this problem and now we have some space. So that's why it is called as GPR, general purpose register. Means a programmer can use this space, can use this space as per they think of their program. So they can use it. Now we as the programmer or the coders of our microprocessor can decide that what is going to happen inside of it. or what could be the structure, the possible structure for it. Okay, so what does that A, H, B, H, or just simply let's say AX, BX, CX, and DX actually mean? What is the meaning of A, B, C, D? Is that random? Nothing is random in our subject. So AX is, let's write a little bit and then we're going to understand everything. So what we are having in the AX, A is actually accumulator. Well, I hope if you have followed the videos earlier, you surely have gone through this word multiple times. Accumulator register. So AX is accumulator register. This is used to store operands for arithmetic operation. Arithmetic operations. OPERATIONS. Okay, so this is AX. Now let's talk about the PX. Well, can you guess the name, my dear friend? Surely we can. B is for the base. We need a strong base. So this is our base register. So this is our base register. This is used to store the starting base address of the memory area within the data segment, So, well, this is a base register and used to store the starting base address of the memory area within the data segment. Well, I think it is self-explanatory, but don't worry, we are going to see the whole execution of our processor once we go through every of the execution unit thing, because that's the most important thing. Ultimately, we want to learn that how it actually works. Without that, whatever we even try to do is just like the clouded thing in our head. So we are not going to have been clouded and walk like, oh, there's something magic is happening. No, we are not going to like that. We are going to be smart and we are going to learn everything. Nice drawing, right? Seems like it's running. Okay, so what is CX? Well, C is counter. So counter register. Counter register. Well, as the name suggests, it's just count down the thing, 1 2 3 4 type thing. It is used in loop instruction. If you are programming the things, you surely know about the loop, like while, for loop, while loop, do while loop, and all kinds of things. Loop means when something is repeating again and again and again. Well, unless you determine something, it will run to the infinitive. That is called as loop. Obviously we need to store the loop, so it is also used to store the loop counter. Store the loop counter. So next time you write for loop, do while loop, or while loop, whichever the loop you are using for your programming purpose, if you're programming the things, remember that inside the processor, who is taking care of it? CX. But you should have to be a little older version of yourself, because we are talking about the 8086. But surely in our modern computers too, there is a register to deal with the loop instruction. So yes, it works. So that's what you have to think. Hmm, we will talk. Just let's write first. Just finish writing up. Okay, so the TX thing is, well, that's just holds input output port, input output port address, actually port address for input output instruction, input output instructions. So that's the whole idea of it. I hope you have got the thing, but we're going to see that, of course. So what you actually must intend as an engineer, as a scientist, as a student, what a microprocessor student must think when they code. Not just the microprocessor architecture, but when you're doing the simple coding like in C programming, C++, even in your scripting languages, HTML, CSS, JavaScript, Python, Ruby, Perl, whichever, you just name it, Kotlin, Swift, making the app, well, whatever you are doing. What is happening there? You are writing the logic, compiler is compiling the things or translating the things into the what we can say, the simplest machine language, zeros and ones. But what actually happening is the voltage fluctuations based upon the architecture of the microprocessor. When you're writing the loop, the CX is getting activated. It is looping the things like 1, 2, 3, 4. It is making the numbers. It is doing the logic. The microprocessor is processing the things, and we can get the update on, we can see that on our screens as the output, or we can store that in our memory. But what a microprocessor person must think, what you must think from right now, is that these things are happening inside the processor, and these things are collecting, incorporating, and enhancing the ability. These are the things which is giving you the ability to code. Well, with all that said, in a more dramatic form, okay, um, what we are left with? We are left with the, well, these things. We are going to talk about these things as P, B, P, S, I, and D, I. I'm not going to bore you with that. I'm going to tell you straightforward that what these are. So let's do it. So what is our SP? Well, S means stack. So this is stack pointer. Stack pointer. Well, if you want to know the name of all these things, that what this entire thing is called as, like the previous one was called as the general purpose register, as we have seen here. The general purpose register is this one. Okay, so now what are these ones? Well, wherever you see the P means pointer, like even now I wrote the pointer. So this is stack pointer, base pointer, source index, and data index. Yes, not always the pointer, there is index too. So what we need to think, these are the offset addresses that must be known to you. Well, we are going to see that, but that's the whole idea of it. Okay, so let's write it down and let's learn that what it actually means. It points to stack up, to stack up. Actually, I should write stack top, points to stack top. During the instruction, well, whenever the instruction is going on, let me give you the examples. Push, pop, call, etc. I'm writing the etc. Okay, what is the idea here? It is stacking up the thing, pushing the data, popping the data. Well, if you have done a few of the programming or data structure, you surely know about this. Well, I hope you are now realizing that how powerful this subject is. We are studying a technology which was so old, but we have to take care of so many things. So, because you are not just creating a machine or device or just a processor, you have to organize it in such a way that when someone codes on it, when someone uses any kind of algorithm, it should work, because everything actually works on practical basis on the physical space. So I'm sure that you have gone through these kind of things, like these are the stacks that we are having. So there is push means you can push the data, like I want to push the a in this space, so I can push it. Or in the other words, like if I have let's say here, let's say I am having the b, so I can pop it out. This is b. So these are the keywords that we use generally in the data structure, but we have to care about the data structure too. Well, why should we have to care about that? Because when a computer science engineer, like in our case, a programmer, is coding anything, or algorithm, they are trying to make some algorithm out of it. So what we need to understand is they can do all the logical combinations, all the logic they can apply. We must have a physical aspect for it. They must have a physical space for it. We must have a pre-prepared architecture for it. That's why the processors are keep on developing as per the needs, because our program is getting more and more complex. Now you don't want to just program a street light. Now you want to program the rockets. Now you want to program the Mars rover. Now you want to program the Chandrayaan. That kind of the level of things. It actually requires that kind of the understanding. So when we study the microprocessor, we become the code, we become the algorithm, we become the data structure, we become the digital electronics, because we have to understand the core architecture, that whatever is happening because of the reason, and you are the person responsible that that reason should work. So that's what the real meaning of understanding the microprocessor, and that's actually is more emphasized on all the possible classes for the microprocessors specifically. And I think this should be given more priority than the data that we are studying. Like these are the things, these are the data that we are understanding. More complex is the processor, more complex is the thing, but the most important thing is whatever you're doing, try to relate it. Maybe there are better logic for the better processor, or a different kind of the processor or microcontroller when you study, but surely the basic, the logic, the architecture must be the same. Okay, with all that said, let's back to the BP. So what is a BP? B is base pointer. So B is the base. Also the B was the base register. This time it's pointer. So base pointer, what a base pointer is do? Base pointer holds the offset address. Well, let me also write that so that you can see that too. It holds the offset address. Offset address. And it can stack up any location, the stack segment. It can be used to random location. Actually, everything is stacked up, so it can help about the offset address. It can just pick out that address. It can tell you the location. Well, the keyword you can remember for this one is location. So it is having the location. One part of the location is called as offset address. Okay, now what is next one? Next one is having SI, which is source index. SURCE, source index. Well, I have written SI. So I changed the format of the writing, like I am writing BP here, and then its full form. Now I am writing the source index first and then its shorter form. Abbreviation first. Why? Because these two are similar. That's why, nothing else. Okay, get back to it. Um, Sometimes few of the fun is also interesting. If you remember these movements, you will remember the microprocessor sometimes when it seems so complex. Okay, it holds the offset address in data segment. It stores the offset address in data segment. Data segment. Well, if you look closely to its name, it's about the source and index. Well, in the general word, we sometimes use the word index for the content, like chapter number 1 is from page 1 to page 20, and then 21 to 44 is chapter number 2, and this kind of things that we are having. We also call it content or index. So it stores the offset address in data segment. Well, if you notice closely, you might already have noticed it, that offset address. Yes, both are the same thing. But in this one, it is having data segment, and in this one, I have not written it here, but it is stacking. It's about the stack. Actually, stake. I should write it clearly. Stake stack. I think you can get my handwriting. This is this stack. That's it. The first one. So it is correlating with this one. And this is having data segment. Data segment, what the data segment is, it is talking with the memory. It is talking with memory, the physical memory, the outside memory, talking with memory. Well, I'm not talking about that it is connected to the memory directly. I'm saying that it is having a logical connection with the memory that is outside of our microprocessor. That's why execution unit sends to the PIU that what it requires, and finally the PIU gives and get back to it. So we have studied the 3 points here, and now it's time for the fourth one. So the fourth one here that we're having is destination index. Well, why my voice suddenly became like this? Well, because we have already reached to the shore of the architecture. This is destination index. So we can write it DI. Okay. I should make it like this. Okay, just the drawing part, nothing else. No physical significance. It holds the offset address. Let me write it also. It holds the offset address of extra segment. That's it, nothing else. Holds offset address. I'm just writing the shorter form because I think you already get the idea. Everything is offset address, and even this one is the part of the offset address. I'm not written to bore you. So it's offset address in extra segment during the execution, obviously, because we are inside the execution unit right now. During execution. Well, I'm also going to add my short notes on the entire architecture, in which maybe just I hope in just 5 or 6 pages, I guess. You can have the clear understanding. If you want it word by word, you can get it from there. You can just read it out and you will understand the entire story that we have learned. And if you want to extensively learn it again, you can just rewind the video and can go one after another, and then you will understand that what is happening, why it is happening, and what is actually going on. Okay, so we have crossed the definition part, the theory part of it. Now let's come to our interesting part. So execution unit is someone, a guy, who is going to execute the things. Yes, I am the boss. So here is the boss. Well, BIU is a great stuff, um, a great team. Let's say it is having teamed. It is teamed up with EU. So what the boss is doing here? The boss is just presenting the instructions. Hmm. Yes, some way. Okay. So first of all, we need some space. The boss needs some space so that it can distinguish the things AX, BX, DX, CX, and all that kind of things. So AH and AL and these kind of things that we are having till the T, and it is called the AX, and similarly. So what is this? General purpose register. So it has to store the work for everyone. Yes, the work for everyone which is going to get executed. Hmm, that took some operation, right? And below this, there is connection of the offset address. Offset address. Just take for an example the imagination. Like I have a question, a query, as execution unit. I have a query that I want to see the file number 2046 again. So what I have to do? I have to look for its offset address to execute it, or just to even read it. And then I have to follow the entire thing. Well, this is not the best example. Let me choose the best example. Okay. So as the boss, what you are having here, you are having the offset address, means the person who can, well, it's not the physical person, but let's say this is the person, the people who is having all the location. Like you are having all the location, like let's say the data 1 is living in 0 1 0 0 0 1 space. Well, I took just a random space number here. So what it is going to do, it will going to go all the way to the memory, process everything, and then it will going to execute it. I think you get a very slight idea from this one, but I will try to manage in the next one. Okay, so that's it for this one, and now we are going to see the remaining part, the last part of this microprocessor section 8085, the entire architecture. We're going to wrap up the thing, and in that one, I'm also going to tell you everything that how it's working, because till this point we are just being theoretical. So I'm going to make you explore, imagine that how the processor is actually working. So till that time, take care, God bless, and see ya in the next one.